Right, here we've got a pulley question. This is, there's two masses here, mass 1 and mass 2. They've got the masses, 2 kgs and 6 kgs. Right, at the start of the experiment, the bottom of mass 1 is 1.2 metres above the floor, and both masses are stationary. Calculate the gravitational force on M1. Include the correct unit in the answer. The first thing I noticed when I read this question was 1 mark. Okay, it's not a particularly hard question. Some people got a little bit carried away with this. It's a really, really easy question. You've got to remember, if it's a 1 mark, it usually only involves one step of a calculation. The gravitational force on M1, well, here's M1 here. Gravitational force, you can call it the force of gravity, or you can call it the weight force, equals mg equals 2 times 10 equals 20. What's the unit for a weight force? It's a Newton, it's a force. And they hadn't actually given us the unit in the question, and the answer. They actually wanted us to do that. Right, calculate the tension in the string as mass M1 is falling. As mass M1 is falling. Alright, the way I go about these questions, for me to understand them, is I draw all the forces on them first, and then I'll show you what I do. So, there's a 20 Newton force downwards on this. There's also a tension force backwards. It's not as big as this because the whole thing accelerates. That same tension forces here are equal to each other, pulling that way. There's a 60 Newton gravity force down, and it's the same size as the normal force up. What I do with this is I say there's a pulley here, and I open up the pulley. So here's where my pulley was, but instead of going around the bend like that, I just open it up so it all goes in this direction. So I've moved this M2 all the way up over here. But I have to swing around. As I swing that up there, I swing around the forces as well. So I've got this tension force, 20 newtons here. I've got the mass here. Now this tension is now going down. It's not that big. Because it's swung around. They're the same size as each other. And the 60 that was up is now swung over this way. And the 60 that was down is now swung over this way, and they're the same size as each other. So now if you look at this whole system here, what do you see? They cancel out, and they cancel out, and all you've got left is the total force on the system is 20 newtons. So the first thing I'm going to do with that is I'm going to say A equals total force over mass. I got that from total force equals MA. So I'm going to work out the acceleration first, how fast they're accelerating. I'm going to use that to work out tension. In this case we have that equals 20 newtons, the total force on the whole system, and that force is accelerating all of these. At 20 newtons is pulling this and it's pulling this. So the mass I use is not 2 kgs, it's not 6 kgs, it's 6 plus 2 is 8 kgs. Which equals 2.5 meters per second squared. So that's how fast these masses are accelerating. This is accelerating at 2.5 meters per second squared. This is accelerating at 2.5 meters per second squared. I can use that 2.5 meters per second squared to work out the tension force. What I'm going to do is I can choose any of these. It doesn't matter which one you do. You'll do the same calculation. It turns out this one's a little bit faster to use this mass. And what I'm going to do is I'm going to calculate the total force on number 2, mass 2, which equals MA, which equals the mass of number 2 is 6 kgs, and the acceleration of number 2 is the same as acceleration of number 1, 2.5, and you get 15 newtons. That's the total force now, not on the whole system, just on this guy. So 60 up, 60 down, they cancel out, and tension add together to give 15 newtons. Therefore my tension equals 15 newtons, because it's the only force left over after those two cancel out. So the total force on 2, it equals the tension on 2, which is 15 newtons. You could have done the same thing on 1. In fact, let's do the same thing on 1, just as a little aside if you want to see it, okay? So I'm going to do it down the bottom here. Total force on 1 equals ma. The mass of 1 is 2, and acceleration is 2.5, so that equals 5 newtons. The total force on mass 1 is 5 newtons. So total force on 1 equals 5 newtons. Now obviously it's accelerating downwards, so it's down. That's made up of its actual forces, which is 20 newtons down and tension up. It's made up of 20 newtons down plus some tension up. 20 plus something up has to equal 5, while tension has to equal 15. Okay, because 20 down, 15 up gives 5 down, which is that. Same answer, 15. So you could have picked both to do that working out, but through experience, because you've practiced these so many times, you'll know that it's easiest to pick M2 because you don't have to do that subtraction at the end.